So in electrostatics, in moving charges and magnetism, have you studied equilibrium? Equilibrium, just to say for example, if this is the direction of electric field, this is the direction of electric field. If you have something minus q here and plus q here, okay, just this is one position. Same way electric field like this, okay, if you have q here and you have minus q here, okay, so this is one position. Same way if this is electric field and if you have minus q here, okay, plus q here, if you have this kind of thing, what will happen? Which direction force will apply? Force will be in this direction. What about this one? Force will be in this direction. Definitely it will come back to which one? This alignment. Okay, so leave this. Okay, now come here. This is what kind of equilibrium is this? Stable equilibrium. This is unstable equilibrium. So இது யாருக்கு தெரியாம இருக்கு? Can you just tell me, anyone who do not know about equilibrium, stable equilibrium and unstable equilibrium? எல்லாருக்கும் தெரியும். யாருமே கை தூக்கலைனா I will ask a few questions and we will make very enjoyment. Everything will be very funny. So 3 வரைக்கும் என்றேன். அதுக்குள்ள எல்லாருக்கும் தெரியும். யாருமே கை தூக்கலைனா I will start asking questions. Number 1, number 2, ஒரு வாட்டியோட தான் கவுண்ட். கரெக்டாக யார் மேலே சந்தேகம் இருக்குதோ அவங்ககிட்ட கொஸ்டின் கேட்க போகிறேன். ஃபஸ்ட்டு கொஸ்டின் கண்டிப்பாக முகேஷுக்கு தான். ஓகே, அப்போ ஓகே, இனி வேண்டாம், கை தூக்க வேண்டாம், தெரிஞ்சது. ஸோ நத்திங். See, look children, இது என்னது? ஒரு vessel. This is a vessel. This is a vessel. So here we kept a ball. Now if I displace this ball to this side, where it will come? It will come back. See? So wherever we displace, it will come back to original position, mean position, or equilibrium, stable position. This is called stable okay, stable equilibrium. Come here. If I displace this charge like this, எப்படி இருக்குதுன்னு வெச்சுக்கங்க. Okay, this is plus q, this is minus q, electric field. So if I displace this charge like this, what will happen? Force is happening in this direction, kudum. Not kudum. What will happen? Actually, what will happen? It will oscillate. It will oscillate. This also will oscillate because of friction only in there. That we will study in the next chapter. So this is going to oscillate. But just understand that it is just one movement. If we consider it, if we replace like this, it will come like this. So that is the reason that is stable equilibrium. We can say this is also stable equilibrium. Okay, so same thing. If this is what? Magnetic field, and if we keep a magnetic dipole, this is north pole, and if this is south pole, if you displace like this, same kind of experience this will also have. You might have covered moving charges and magnetism. So at the end, what is there? This is coming. Magnetism and matter, this discusses a lot. In magnetism and matter, there only this pole strength will come. Instead of q, we will have here m, pole strength. So instead of here we have P is equal to q into 2L, here we are going to have M is equal to M into 2L. magnetic dipole moment, electric dipole moment, vector, vector. So here also what will happen? It will come back to same position. So this is what is stable equilibrium, stable equilibrium, stable equilibrium. Clear? Clear or what? Okay, fine, understood. Shall I erase this? Okay, in simple language, another way. Okay, யாருக்குமே suppose stable equilibrium என்னப்பா வெளியில இருந்து நீங்க டீ சாப்பிட போகும்போது someone called and asked, so when you explain அது என்ன சார் வந்து எலக்ட்ரிக் ஃபீல்டு இப்படி இருக்கும்போது நம்ம வந்து எலக்ட்ரிக் டைபோல் இல்லை அது இப்படி வச்சுட்டு இப்படி பண்ணிங்கன்னா அது இப்படி வரும் இல்லைன்னு சொன்னீங்கன்னா வாட் he will say, எனக்கு படிக்க முடியாதுன்னு சொல்லுவாங்க. physics is not my cup of tea. நீங்க சும்மா சொல்லுங்க அந்த கப்பையும் கொண்டு வா, கப் எடுத்துட்டு அதுக்குள்ள ஒரு லெட்டு போட்டுட்டு if you shock it, it is coming back to இதுதான் stable equilibrium. Okay, அப்படி சொன்னா he will understand. So நம்மளே மாதிரி சாதாரண மக்களுக்காக another explanation. This burden, this vessel you have taken dumb, you kept like this. On the top of it you are keeping the leddu. This is also equilibrium. Leddu is there. Leddu is there. This is also equilibrium. But what will happen? Simply I made a motion, a jerk. What will happen? It will fall back. This is called unstable equilibrium. Okay, this is called unstable equilibrium. So here in this position what will happen if you displace like this? Q will come here, the force is in this direction, QE. If minus Q comes here, if this is the direction of electric field, force on minus charge will be in which direction? Opposite to the direction of electric field. The force will be opposite to the direction of QE is what force? This is also force. What will happen? It will come to stable equilibrium position. Okay, chinna light konjam da idam koduthe adukulla ennachu everything turned. Okay, light it will come back to this position. Torque will act and it will make it 180 degree turn. This is what is the example for unstable equilibrium. Clear or what? Suppose somewhere like this on a plane, if you keep something, this is nothing but neutral equilibrium. Neutral equilibrium. Clear or what? So F is equal to, idukku ellathukkum base enadhu, F is equal to minus du by dx. We have written F is equal to minus du by dx. Equilibrium means what? F is equal to 0. F is equal to 0. Equilibrium means F is equal to 0. So this is 0 allava. So if we get a potential energy function, if you differentiate it, if you do du by dx, if it is 0, it is stable equilibrium. This is also what? Stable equilibrium. This is also what? Stable equilibrium. Done. So if we get a potential energy function and if you differentiate it once and if you are getting 0, that is what? Force is equal to 0 and they are all equilibrium, some equilibrium. Okay, either stable, unstable or neutral. Okay, so those who do not know, please note down this. Okay, now suppose if you do, now we need to know whether this is stable or unstable or neutral. We want to know. So what we can do is all 0. If you differentiate this again, d square u by dx square, I think this is greater than Okay, then this is going to be stable equilibrium. Okay, just differentiate it again. If you are getting greater than 1, that is stable. Differentiate this one again, t square u by dx square, if it is less than 1, and stable. And if you are getting d square u by dx square is equal to 0, then that is going to be neutral equilibrium. See children, generally if this is what is this is potential energy, this is potential energy, so this is going to be x based on distance only potential energy will change. See, if we are lifting this dumbbell, if I keep on standing like this, like a statue, potential energy will be constant. So potential energy is not a function of time now if it is same position, but if I am decreasing or increasing the position or x or y, it is changing. So generally potential energy is a function of distance. Okay, so now suppose if we do a curve like this, if I do a curve like this, so this position, is it an equilibrium? Wherever, yeah, see, du by dx du by dx is slope of potential energy distance curve. Du by dx is what? Slope. Du by dx is slope. So wherever slope is 0, here slope is 0. Ingame ennathu? Slope 0 allava. Ini inge? Slope is 0. So all these 3 points are equilibrium. All these 3 points are equilibrium. Wherever we have minimum potential energy, what is that? Stable equilibrium. So this is the stable equilibrium. Wherever equilibrium da, but potential energy is more, this is unstable equilibrium. Okay, that's it.
So this is 1 or 0, sir?
This one?
1 or 0.
That is 0 only. Okay, I did a mistake. The intention was 0. While writing, wrote 1. Okay, so that is going to be 0. All are 0. Equal to 0 means this is going to be stable, neutral. Okay, so greater than 0 means positive, less than 0 is negative, then if equal to 0, then it is neutral equilibrium. That's it. Okay, thanks for asking. Okay, otherwise this would have taken throughout. Okay. Okay, done. Clear? Erase Manava. We will do some problems. தப்பு தமிழ் பேசும்போது ஹெல்ப் பண்றது இல்லை, உதவி செய்யற பழக்கமே இல்லையோ. U is equal to x square minus 8x. U is equal to x square minus 8x. Okay. Find the position of equilibrium and type of equilibrium. Find the position equilibrium. Type of equilibrium. Okay, so this one F net should be what? 0 for equilibrium. So what we are doing, minus du by dx should be equal to what? 0. So minus of, if you differentiate this, we will be getting what? 2x minus 8 is equal to 0. So what will happen here? 2x is equal to 8, x is equal to 4 meter. So at x is equal to 4 meter, we have what? Equilibrium. Now what is the type of equilibrium? Okay, so what should we do? D square u by dx square. So whatever we got here, we need to differentiate again. We will be getting 2. So what is this? Greater than 0. So this is going to be stable. Another question, u is equal to 12x minus x cube. Same question, find position and type of equilibrium. So position is what is the answer? 2. Then minus 2 and 2. Then which is unstable? Minus 2 is unstable. Minus 2 is stable. Then this is unstable. So this is the answer. Okay, let us verify. So minus du by dx is equal to what? 0. So differentiate this, we will be getting what? 12 minus 3x square is equal to 0. So this is going to be 12 is equal to 3x square is equal to 4. So when we take x, okay, minus 2 into minus 2 is also 4, 2 into 2 is also 4. So we must take two positions, minus 2 and 2. So again, now if you differentiate this again, d square u by dx square, what we will be getting if you differentiate this? We will be getting minus 6x will be getting. Minus 6x will be getting. Since this was constant, directly comment. But now when this is minus 6x, for x is equal to minus 2, d square u by dx square is what? 12. So this is stable. Same way, if x is equal to 2, what will happen? D square u by dx square is equal to minus 6 into 2 is minus 12. So this is unstable. So in this way we will have to handle them very carefully. Okay, clear? Okay, done. Suppose if we get a curve like this, okay, so this is one position, this is one position, this is another position. So if you name this as A, B, C, okay, which one is stable, which one is unstable? Okay, so this is stable and this is also stable and this is unstable. Okay, so even though the potential energy of this one is, suppose this is how. If I mark like this, for example, here if I keep, the potential energy of this one is greater than this one. Potential energy of this one is greater than this one. Still, this is the stable equilibrium, because this all depends on the local maxima, local minima. Such a concept is also there. Okay, so this is unstable, that is stable equilibrium. Clear or what? Okay. Now come take that handout, children. Okay. Yeah, question number 29. Question number 29. Question number 29. The potential energy of a body is given by U is equal to A minus B x square. Okay. The magnitude of force acting on the particle is proportional to x. ரொம்ப easy la? Okay. So magnitude of force acting on the particle is proportional to, so F is equal to minus du by dx. So minus d by dx of A minus bx square. So this is going to be minus 2x minus 2bx minus 2bx, correct? 2bx. So this is proportional to x. Okay, next question. U is proportional to x. Which option? B. Okay, done. Another question. Okay, the potential energy of a system is represented in the figure. Question number 30. Okay, so the potential energy of the system is represented in the figure. The force acting on the system will be represented by option C. Okay, any other answer? Okay, Dharani gave option C. Any other answer? A. Okay, so here the potential energy curve is given like this. Okay, so U of x and this is x. Okay, what they are asking? Simply they are asking force. So come to the fundamentals, that's it. So F is equal to minus du by dx. What is this? Straight line. If you differentiate straight line, what it will become? This will become constant. Simply this is nothing but the equation of straight line. If I write y is equal to mx, திருப்பி ஏன் இது சொல்றேன்னு பாத்தீங்கன்னா, those who don't understand, at least in the previous case, must understand this time. Y is equal to mx. So if you differentiate this dy by dx with respect to x, if I do, what will happen? This will become m. correct? This will become constant. Mn ഒരു constant 2 3 4 time poga 2 4 3 will be 4 2 4 3 only, so that will become constant. So if I differentiate this one, this is x, okay, leave, if I am not going to put, just I am putting force. So when I differentiate this one, whatever be the m value, likewise I will be getting a constant value. This is already constant. Differentiation of constant d by dx of, suppose if this is 2, this will become 0. So here it stops, but here there is a negative. There is a negative. So when I flip this, what I will be getting? I will be getting curve like this. Okay, so differentiating figures, nothing is there. Nothing is there. Suppose if you get a parabola, if you get a parabola like this, if you get a parabola, if you differentiate it, what we will get? Straight line. This is nothing but kx square. This will become 2kx, some constant into x value. If x comes, what will be there? This is going to be straight line. So this will become, if you differentiate this, this will become a straight line. Bas, over, very easy. Clear or what? So what is the answer for that question? C. C is the answer for this question. Okay, done. Okay, what is the next one? A particle moves in a potential energy region is given by u is equal to 8x square minus 4x plus 400 minus 4x plus 400. Yes, its state of equilibrium for what x? That is a question. Okay, its state of equilibrium. So question number 31. So the equation of potential energy is given as 8x square minus 4x plus 400. Okay, so this is nothing but f is equal to 0. State of equilibrium means f is equal to 0. So du by dx minus du by dx will be 0. So minus of, this is going to be 16x minus 4 is equal to 0. So 16x is equal to 4, x is equal to what? 1 by 4. X is equal to 1 by 4. So x is equal to 0.25 meter, answer B. Okay, clear? Done? Okay, next question is regarding spring, spring. So we'll discuss sometime regarding spring, then we'll come back. Okay, done. So here a spring, a mass m. So if the spring constant is k, suppose if we start applying an external force, what will happen? When we start applying external force, just like in the case of elasticity, okay, when we apply an external force, this will elongate, and how much force we have applied externally, the same force will be developed by the spring as restoring force in order to bring back the spring to previous position. So suppose if this is the extension, if this is mass m, now I am applying F external, there will be F spring in this direction. What will be the spring force? F is equal to K spring constant, and how much is this elongation? How much is this elongation? Okay, see, this is what is x. So F is equal to K into the elongation. So this is the spring force. Same force will be acting in which direction? Whatever force he is applying, that much will be the spring force. Just because of that reason, F is equal to Kx and F external is equal to Kx is happening there. Okay, so this is the direction of displacement. This is the direction of X displacement, and this is the direction of F external. Okay, and that is the F spring. This is F spring, and that is the F external. Suppose the same case, if we compress, if this is mass M, this is the correct direction. So this distance is going to be x. So F external is acting in this direction. So F spring will be acting in this direction. This is also Kx, this is also Kx. Okay, so that is the fundamental thing which is happening here. Okay, now those who do not know, please note down. Those who know this, leave it. Okay. Okay, children, right. Now what I need to know is, this force is constant or variable force? Variable force, correct. Suppose if the position of mass is here, x will be less, so force external will be less, force internal also will be less. Clear? So the magnitude of external force and magnitude of spring forces are same. Direction is different. Direction is different. So always, since this is acting as a restoring force to bring back to the original dimension, we always put a minus kx for spring force, not for external force, but for spring force. Now, so okay, so I am taking here the elongation is equal to 0, and at this position the elongation is going to be x itself. Okay, from 0 to x. Okay, done. Now work done by spring force. Work done by spring force. This is variable force, correct? So I am putting minus kx here. Okay, minus kx into dx. From where to where? From 0 to x. 0 to x. Okay, correct or what? Okay, now what I need to do here? I need to put a dot here. I need to put a dot here. Fine. Now when we do this, what is the, please integrate this and tell me the answer. What you are getting, the work done. Okay, all of you, please do that and tell me the answer. Half kx square. Okay, so work done is equal to minus half kx square. All of you are getting this? Okay, so this is going to be minus half kx square. Clear or what? Right. So this is the work done by whom? Work done by spring force. Generally the questions will come and half kx square, when we apply, we used to get the answer. But we have to be very careful whether they are asking work done by external force or work done by spring force. If it is work done by external force, what will be the answer? Half kx square. Okay, now what is potential energy? Potential energy is the negative of work done by conservative force. Potential energy is the negative of work done by conservative force. So this is the conservative force or this is conservative force? Spring is the conservative force. So negative should put for this one or this one? We should put for this one. So this is same as what? The potential energy stored inside the spring. Clear or what? Okay, clear? Okay, done. Suppose if without any change in length, if this is the position of the spring and this extension is xi, this extension is xi. Suppose further we are extending to further distance and this distance is going to be xf, then work done by spring force. Understood or what? It is, we are in from an initial elongation to a final elongation. Already an elongation is there. And this is another elongation. So in this case, work done by spring force will be what? Integral from where to where? From xi to x final. This is going to be minus kx dx. So when we do this, what we are getting? Half along with the negative. Along with the negative, what is coming? Half k. Inge x ayya illa xf. Here xf minus half k xi square. Correct? All are getting this? Okay. So this is the work done by spring force in order for getting an additional elongation. So directly you can put the current displacement and the final displacement and get the answer. Okay. So this is there for the change in kinetic energy also. This can be applied. Okay, done. So work done by spring force is minus half kx square. Work done by external force is equal to half kx square. This is equal to u. So okay, this is when from initial position to an elongation. So in this case, work done by spring force of half x square minus half k xi square. Okay, so nothing. If work external is asked, this is nothing but half k xf square minus half k xi square. This is same as the change in potential energy. Okay, so these two things they will ask. So I have seen students getting confusion. This kind of questions will be asked and this formula is remembered, then where to apply, what to do, all these things will be there. Sometimes minus will come here, there, go, comes full. Okay, simple questions. It will be a simple question, but one minus will trouble us. So please be very clear on this. Okay. Done? Okay. So work done is equal to simply half kx square. If nothing is mentioned, whether it is spring or external force, then there won't be any sign in the options also. Negative will not be there. then we need not worry at all. So this is half kx square. Work is equal to, what is kx? F. So if we want, we can write like this, half into fx, half into fx. X is equal to what? F by k. So we can write in this way also, half f square by k. Three variations are there. If one is constant, the other one will be varying. So likewise, just w1 by w2 equal to x1 by x2, w1 by w2 is equal to k2 by k1. This is what our aim is. We need to remove all the constants away, then things will become very small. 20-second question that will become. Okay, clear children? So I think let us solve problems here. Right, so question number 32. Question number 32. Okay, then start doing question number 32. Okay, so question number 32. A long spring is stretched by 2 centimeter. Its potential energy is U. Okay, it is stretched centimeter. The potential energy will be, so U is equal to simply half kx square. So U1 by U2 is equal to x1 by x2. Correct or what? So this is going to be U divided by U dash is equal to, here this is 2 centimeter, this is 10 centimeter. U dash is equal to what? What pa? What is the answer? Is it correct? Square. Now U dash is equal to 25U. Yes, what? Which option? D. Okay, come to question number 33. Has spring of spring constant 5 into 10 raised to 3. Allava, that question. The spring of spring constant 5 into 10 raised to 3. Okay, is stretched by initially by 5 centimeter. X1 is equal to 5 centimeter from an unstretched position. The work required to stretch it further 5 centimeter. So XF. Okay, fine. Again, it is stretching further to X5. Correct or what? Correct. So what is that formula, children? Work done is equal to half K XF square minus XI square. Half K XF square minus half K XI square. So just put it. So work done will be half into this is given as 5 into 10 raised to 3 into it is given as 10 centimeter and 5 centimeter additional 5 centimeter. So we will take out that centimeter, 10 raised to minus 2. So final position is actually 10 minus 5 square. Is it correct? Final position is 10 centimeter and initial position is here 5 centimeter. Here we will have to write 10 raised to minus 4, correct? This is because of square. How much the answer is? 18.75. Okay. Is it okay? Fine, comfortable? Okay. So if you don't know about this formula, or if you are confused about this formula, then it will waste time using the other formula, then integrating all that. Just remember this. Then next question. 2 springs of spring constant 1500 Newton per meter Which is that question? Question number 34. Yes, question number 34. Yes. Two springs of spring constant 1500 and 3000 respectively are stretched by the same force. They will have the potential energy ratio. So which formula has force and spring constant connecting potential energy? F square by K. F square by K. Okay, stretched with the same force. So U1 by U2 is equal to K2 by K1. So what they are asking? Ratio they are asking. So K2 by K1 is 3000 by 1500, 2:1. Okay, which option? C. Option C. Done. Next is question number 35. A body is attached to the lower end of a vertical spiral spring and it is gradually lowered to its equilibrium position. This stretches the spring by the length x. This stretches the spring by the length x. If the same body attached to the same spring is allowed to fall suddenly, what would be the maximum stretching force? What would be the maximum stretching force? Okay children, how to do that one? So in equilibrium position, suppose, okay, suppose some extension is there. Okay, suppose if this is x, this is going to be mg. Mg is in this direction, then the spring will be applying a force in the opposite direction. So equilibrium position means nothing but mg is equal to what? Kx. What is the thing they are asking? Okay, so this is one condition. Now next thing is when the spring is allowed to fall suddenly, what will happen actually? See pa, the thing is, suppose if this mass is here, okay, now keeping this mass, okay, now what is this? Equilibrium position. Okay, mg, kx, everything is same. Okay, romba rough okay, left it like that. Friction alla illa, நம்ம எங்க இருக்கு போ, நம்ம எர்த்துக்கும் ஜூபிட்டருக்கும் இடையில நின்று, all classroom is in space. Okay, friction எதுவுமே இல்ல. Okay, suppose if I push Bala, Bala will go to Saturn. போயிட்டே இருக்கும். Someone will have to run and bring it. No friction. Simply if we leave it, what will happen? It will oscillate. It will oscillate. Right. So regarding oscillation, if we study, then only we will be able to deal that. So F is equal to minus kx. F is equal to minus kx is the condition for oscillation. F is equal to minus kx. So that we will apply here. Okay. F is equal to minus kx. If we apply, that is the condition for oscillation. Now here we don't have much application, but only for this problem slightly. So what will happen to the force now? I mean what they are asking, when the spring is allowed to fall suddenly, okay, what will happen? It oscillates in its mean position. Suppose the magnitude of vibration or the frequency of vibration is there. No, frequency of vibration is there. Frequency, it will be vibrating and it will have a magnitude, I mean the magnitude for the amplitude. Suppose if it is moving like this, this will be minus a, this will be plus a. What is the magnitude of amplitude? Is a, simply. So suppose if it is going to oscillate like this, if it is going to oscillate like this, there will be plus y, minus y. Okay, so what happens is, if it is stretched to the maximum, we can say the work done will be mg into that y, mgy. Other side, how much will be the force? Extension will be what? Y. So this is going to be what? Half k y square. Sorry, mgy. Mgy is equal to half k y square. Now, what is given in the option? What they are asking? What would be the maximum stretching in this case? So what they are asking is actually y. So y is equal to what? K y square. Okay, y and this one will be cancelled off. So this is going to be k divided by 2 mg. Correct or what?
No, sir. 2 mg by 2 mg.
Sorry, y is equal to 2 mg divided by k. Y is equal to 2 mg divided by k. What is kx? What is x here? mg by k. So here what is coming? 2x. Bas, over. So y is equal to 2x. Okay, so that time we will have to deal like that. I explain again, children. See, if we are simply leaving this slowly, things will be simple extension. Okay, mg is equal to kx will be the equilibrium position the force is. Now suppose if we are simply leaving just like that, it will oscillate. It will oscillate means it will have the maximum amplitude, maximum displacement. Maximum displacement is the amplitude. So if we assume that amplitude as y, then mg into that y is the work done by the force, this force. That will be same as the spring force, that is nothing but half ky square. So now substitute the value of x here, get the value of y in terms of x. That's it. Okay, clear? Question number 36 this session. Okay, two equal masses are attached to two ends of a spring of spring constant k. The masses are pulled out symmetrically. Stretch the spring by a length x or its natural length. The work done by spring on each mass. Okay, so that is a question. Done. So spring, suppose if this is the spring, this is one mass, this is another mass. Okay, so this is stretched, so the stretch is nothing but x anyway. Two masses are there, but stretch is how much? X. Okay, now what they are asking? Okay, now the work done by spring on each mass. Work done by spring on each mass. So work done by the spring will be generally what? Half. Okay, half k x square. Half k x square. So when this is done on each mass, if we consider work done by the spring on each mass will be what? Total work done, actually in this the stretch is x, so total work done is going to be half k x square. This is the total work done. So if they ask what is the work done by the spring on each mass, again by 2, simply energy. So if we divide this by 2, work done by spring force on each mass will be nothing but 1/4 kx square minus if it is spring. So work done by spring on each mass will be minus 1/4 kx square. That's it. Clear? Any doubt in that? Okay. Okay, next, a proton has, which this question number is what? 36. Done. Next question is 37. Okay, the question is, a proton has positive charge. A proton has positive charge. If two protons are brought near to one another, the potential energy of the system what will happen? Increase. Okay. That is what. If there is only one proton, then kq into 0. So initial potential energy will be 0. If we bring another proton there, k q1 q2 by r. So obviously the answer is increase. Okay, simple question. Your electrostatic basics is enough. Second one, question number. Okay, so this option A done. 38. Two protons are situated at a distance of 100 from each other. Therefore, the potential energy of the system will be, okay, they are at 100 Fermi proton. So U is equal to what? The formula is K Q1 Q2 divided by R. Okay, so this is going to be how much? 9 into 10 raised to 9 into 2 proton. So 2 into 2e into 2e. So let us write this like 4, I'm sorry, E. This is not alpha particle, right? So E into E. So 1.6 into 10 raised to minus 19, okay, square divided by, what is the distance? 100 from me. So 100 into 10 raised to minus 15, right? So they have given the answer in electron volt. Okay, they have given the answer in electron volt. So electron volt means this answer will be in joule. So to convert into electron volt, what we should do? Divide with the 1.6 into 10 raised to minus 19. Okay, clear? Correct or what? Okay, so cancel them. Just cancel them. What answer will be getting? Okay, so this one and one square will be cancelled off. Okay, so what will be the answer? 0.44 into 10 raised to 4 electron volt is the answer. Are you getting? Okay, so option D. Option D. Clear? ஏதாச்சும் மனவலி இருக்குதா? ஓகே, யாராச்சும் தூங்கிட்டு இருக்கான்னு பார்க்கட்டும். பாயசம் சோப்பாடெல்லாம் சாப்பிட்டுட்டு ஒரு கேப் கிடைச்சு வச்சுக்கோங்க, அவ்வளோதான். ரொம்ப உஷாராக இருந்தால் தான் வாழ முடியும். 39 சீக்கிரம் சப்ஜெக்ட் கிளம்பிடலாம். ஓகே, 39. Yeah, mercury nucleus. Okay, mercury nucleus. எல்லாரும் சீரியஸா போதும், விளையாட்டு இதெல்லாம் கொஞ்ச நேரம் கழிச்சு விளையாடலாம். ஓகே, சும்மா சொன்னேன், விளையாடுங்க. Mercury nucleus, okay, atomic number, mass number, okay, is bombarded with by alpha particles with a velocity of 10 raised to 7 meter per second. Alpha particle. If the alpha particle is approaching the then the distance of closest approach will be, the distance of closest approach will be, எங்கேயோ பார்த்த மாதிரி இருக்குல்ல? Just I am mentioning that a law of conservation of energy also here. Okay, look here children, conservation of energy. Okay, suppose a particle, okay, if this has got some movement, if this has got some velocity, if this has got some velocity, has got some height, or if it is undergoing any force of attraction or repulsion, all these things, then this will have what? A potential energy also. So let us consider its kinetic energy. Initial is Ki, and this initial energy, this is going to be U final. Initial, clear or what? Okay, so this has got a kinetic energy Ki, and this has got a potential energy Ui. Now suppose if its velocity and its configuration or its position, if it is changing, okay, this is going to have another velocity, okay, if this is Vi, this is Vf, and its configuration or its position, if it is changing. Now this sound is clear? It is clear now? Okay, so this will have a final kinetic energy plus a final potential energy also. Okay, so kinetic energy, we know, if this has got a velocity half mv square, here velocity changed, half mv square is also changed. Potential energy, this can be due to height. This was the height, now this is the height, correct? Initial potential energy, final potential energy, initial kinetic energy, final kinetic energy. Done? Clear? Now two charges here, initial potential energy, now someone left it, now distance is increased, final potential energy. Initial potential energy, initial kinetic energy, final potential energy, final kinetic energy. Charges, same way, two masses, initial potential energy, gravitational potential energy, kinetic, initial kinetic energy. Now they are separated, final kinetic energy and final gravitational potential energy. So the thing is, these both will be what? Equal. This is what is conservation of energy. Simple concept, nothing is there. Okay, say for example, if something like this is there, okay, so inge irundha bullet la vandu Enfield Java ஒருத்தர் என்ன அல்ல Enfield வேண்டாம், Java போதுமா? Java, it's a Java, in Java or Yamaha RX100 plus. Okay, அப்ப இது இங்க இருந்து போகும்போது என்ன சொல்லுவாங்க இல்ல, so this height is என்ன papas and papis, this is h, this is h, so this has got now mgh, inga varumbodhu what will happen, this complete mgh will be converted into what? Half mv square. So apdiye varumbodhu he will go inga enna agum mgh, same half mv square will become like this. So inga vandu ivar inga irundhu இப்படியெல்லாம் செஞ்சிட்டு இருக்கும்போது what will be the velocity? Zero. So initial kinetic energy is Ki plus Ui is what? 0 plus mgh. inga varumbodhu we are considering this height as 0 alla 0. This height is 0. So here mg, what is the potential, final potential energy here? 0. Okay, half mv square. So what we can write? Final kinetic energy plus final potential energy is going to be half mv square plus 0. Okay, clear or what? So likewise we need to play. Okay, ஆடி விளையாடிட்டே இருக்கலாம். Kinetic energy இருந்து potential energy இருந்து kinetic energy அப்படி. Okay, some enjoyment. Okay தானே? So in the conservation can happen between any energies. Okay, potential energy can be in different form, kinetic energy, okay, most of the time single form. Okay, maybe gravitational potential energy, electrostatic potential energy, okay, or this gravitational potential energy, anything can come in all these things. Clear? So adukku thanda mari we will change our approach. Clear? When the question is no. Okay, is it clear? Is it clear? Right. Question number 39. யார் அது? Okay, children. So coming back to question number 39. So, closest approach. So here, what is there? Mercury. Okay, mercury atom is there, mercury nucleus. Okay, mercury nucleus is there. Alpha particle is coming from here. Okay, so is bombarded with a velocity 10 raised to 7 meter per second. Okay, bombarded. Okay, then distance of closest approach. So it is coming like this. This is Hg. This is Hg. இங்க வரும் வந்ததுக்கு அப்புறம் போறது இல்ல, not able to go. Okay, Hg is not allowing such electrostatic repulsion. Okay, so inga varaikum vandadukku appuram it is not able to move. So this is what is the closest approach, distance of closest. So inga oru initial kinetic energy, oru initial potential energy, inga enna final kinetic energy, final potential energy, right? So what is the initial kinetic energy here? Half m. Okay, what is the mass? 1.6 into 10 raised to minus 27. என்னது? என்னப்பா? Half mv square is equal to, this is half mv square. Okay, leave it like that. Plus inga energy 0 at far distance. Here kinetic energy is going to be 0 plus what is the potential energy? K Q1 Q2 divided by R0. Okay, now here what we can write? 9 into 10 power 9 into what is Q1 alpha particle? Enna? What is the charge? 2e. So 2 into 1.6 into 10 raised to minus 19. What about this one? 208 and 80. So what will be the charge of this nuclei? 80 dane? Any doubt in this? Yarkadu doubt irukka? Question கேட்க போறேன். டவுட் இருந்தா இப்ப சொல்லிக்கோ. 1 2 பயங்கரமா நடிக்கிறீங்க போல. இல்ல தெரியுமா? ஓகே, நோ இஷ்யூ. யூ பீப்பிள் ஆர் கெமிஸ்ட்ரி தெரியும் இல்ல, செம்ம எக்ஸ்பர்ட்ஸ் தான் இருக்கு. என்ன மன்னிச்சிடுங்க, எனக்கு தான் தெரியும். ஓகே, so 80 fine. So this is going to be 80 protons will be there. Atomic number 80 protons will be there. So 80 into 1.6 into 10 raised to minus 19. So this is the potential energy. Okay, this is going to be equal to this one divided by R0. This is equal to half into what is the mass of the alpha particle? 4. So 4 into 1.6 வேற ஏதோ சொல்லிட்டு இருந்தீங்க. 10 பவர் ஏதோ 1.6 into 27 kg. Okay, half m into v square. So this is going to be 10 raised to 40. அவ்வளவுதானே? Okay, just find what is R0. Which option? Option A. Getting option A. R naught will be 1.115 into 10 raised to minus 13 meter. Are you getting this one? Okay, so okay, you can calculate them later also. Okay, another question polama. Question number 40. Okay. Edane? Okay, right. Question number 40. A charged particle A moves directly towards another charged particle B. Okay, a charged particle A moves directly towards another charged particle B. For A plus B system, the total momentum is P and the total energy is E. So option A is P and E are conserved if both A and B are free to move. B is A is true only if A and B have similar charges. Okay, சில ஆப்ஷன்ஸ் அப்படியே அவாய்ட் பண்ணிட்டே முடிச்சிடலாம். ஓகே, ஒரு ஆப்ஷன் புரியுறது இல்லை ஆனால் கண்டிப்பாக தெரியுது இந்த ஆப்ஷன்ஸ் ராங்னு, தென் யூ கேன் எலிமினேட் அண்ட் ஃபைண்ட். ஆப்ஷன் சி, இஃப் B is fixed, energy is conserved but not P. Option D, if B is fixed, neither E nor P is conserved. Which are the answers? Option A is correct or not? Okay, if P and E are conserved, P and E are conserved if both A and B are free to move, no problem. If they are free to move, definitely momentum and energy will be conserved. Okay, leave it. Option B, leave, nothing is there. Option C, if B is fixed, energy is conserved but not P. Correct? Okay, so option A is correct. Okay, option D, if B is fixed, neither E nor P is conserved.
Sir, in option A, if both A and B are fixed means they won't be conserved, sir.
If both A and B are fixed, then there is no momentum, no energy. Both are fixed means no worries. If both are moving, then it is conserved. Okay, what about D? If B is fixed, neither E nor P is conserved. It is conserved, no? It is conserved. Correct? Puriyudungala? Okay. We'll go to next question. Okay, question number 41. Okay, so question number 40, answer A. Question number 41. The work done in pulling up a block of wood, அது உங்களுக்கு பண்ண தெரியும்ல, already that we have given as an example. Read that question, no need to do. Already we have done that example in conservative and non-conservative force example. Correct or what? Answer will come as 41. Answer will be B, option B. Later you can check. Okay, when you practice, after going home you can check. Any doubt? அது படிச்சு பார்த்துட்டு யாருக்காவது டவுட் இருந்தா சொல்லுங்க. Just quickly go through. Okay, so we will move to question number 42. Question number 42. Two identical cylindrical vessels with their bases at the same level. Cylindrical vessels, two identical cylindrical vessels with their bases at the same level, each contains liquid of density D. The height of the liquid in one column is H1, the other is H2. The area of either vessels are A. When the two are connected. This is just like previously, say for example, taken this way. One vessel, the height is H2, H1 more height. The other one is H2 lesser height. Say for example, if this is H1 and this one, this is H2. Now what happens is, once if we connect them, okay, if we connect them, what happens? Levels became same. Levels became same. So work done in order to make the level, work done by the gravity in equalizing the levels when the two are connected. Okay. No problem. Try. Option C. Okay, you want the idea? Hint vedama? See, the potential energy of liquid column, okay? Potential energy of liquid column generally, okay? This is going to be, suppose if liquid height is H, liquid's height is H, okay? Suppose simply any general column, if the height is H, okay, then its center of mass will be here. So take that height. This is going to be the height. Consider the height of center of mass. So this is going to be mg h by 2. Always what happens is just look at the options. Look at the options. What all things are there in the options? A, density, H, everything is there. So if in that case we must understand this is going to be volume into density G H by 2. Another way is A H rho G H by 2. Likewise it will come. So now in this case the potential energy of this one is going to be, potential energy of first one is going to be A E H1 square by 2, correct? The potential energy of this one, okay, is going to be U2 is equal to A rho G H2 square by 2, correct? What is the final height they have given? In order to make it into a height of HR, read the question. Anything is given? Equalizing the height. Avlodhan sollirukilla. Okay, avlodhan. So suppose if we consider this as the final height, if this as the final height, then this system will have, so this is initial potential, these two, the initial A rho G by 2 H1 square plus H2 square, correct or what? Will have what? A rho G H by 2. Any doubt in this? Okay, now what is the work done? Work done by gravitational force is going to be, work done is actually change in potential energy. H square also will be there, yes. Okay, now just simplify this one. Okay, whatever be the change we are getting, that is the work done. Okay, please try. Okay, so here one more thing is there. We need to consider both the height. So this height also we need to consider, this height also we need to consider. So this is h square, that's it. Adding them. Work done is equal to change in potential energy. So rho G h square minus A rho G by 2 h1 square plus h2 square, h1 square minus h2 square. Now see children, what will be this height compared to this h1 and h2? H will be the average height of these two, correct or what? H is equal to so let me put it here. So this is going to be A rho G h1 plus h2 divided by 2 the whole square. I'll be getting here 4 and this is going to be what? h1 square plus h2 square minus 2 h1 h2 minus A rho G divided by 2. So this is okay. A rho G divided by 2. Here this is going to be h1 plus h2 square. Okay, this is how it comes. Okay, just look at this. Is it okay? Do you agree? Purila? Papa? Which one? Idu purila. This is nothing but h1. See, this is h1, this is h2. When we connected, this became h. Means this h will be the average of these two. Okay. Now I have substituted here what? h1 square plus h2 square. See, this is actually h1 plus h2 by 2 the whole square. So I have taken like h1 plus h2 by 2 the whole square, means by 2 4 will come. That 4 I put here. A plus b whole square, a square plus b square. This is what? Minus 2ab. That is minus 2 h1 h2. Okay. Just ask openly. Then this is our final potential energy. Okay, so from this we will get the answer easily based on the option. Tell me. Okay children, so now actually this one when we substitute this here also, actually one small mistake is there. See see, when I substitute for h square, this is going to be a rho g. One side it is going to be by 4 h1 square plus h2 square irukuttum. Again minus 2ab, there also what we need to do, a rho g by 4 what into 2 h1 h2 I need to put, correct or what? Now this is correct. Okay, now see children, this is the call, then ara. So what will be the result? Call will be the result. Okay, so what I can write? Shall I write here? Idellam thevilla. Okay, shall I raise this? Okay, that is not required, right? So when I do this, work done is equal to a rho g divide by 4 minus varma, then h1 square plus h2 square, then minus what, a rho g by 4 by 4 into 2 h1 h2. Now what we are going to do is, we will take this one outside, a rho g divided by 4 minus will take outside, and what is remaining, h1 square plus h2 square plus 2 h1 h2. So can we write this one as h1 plus h2 the whole square? Such an option is there or not? Okay, so minus if we put inside, everything will become negative, no? So somewhere some mistake might have happened. Where it is? Can you?
Plus 2a plus 2a. h1 square plus h2 square plus 2a.
Okay, unnecessary minus came. Right. This is fine, right? So this is going to be, is it true? Is it fine? Correct? A rho g by 4 h1 minus h2 the whole square. So this is option D. Option D. Just look at the solution. If you have any doubt, please ask. Take time, children. Look at the solution peacefully. யாருக்காவது கான்செப்ட் புரியாம இருக்குதா? Any one sentence? பரத், பார்த்தாலே தெரியுது எங்க அப்படி. இந்த ஃபுல் கொஸ்டின் புரியல, எதுவுமே புரியல. ஓ லாஸ்ட் ஸ்டெப் மட்டும், மற்றதெல்லாம் புரிஞ்சுதோ? உண்மை சொல்லு. ஹைட் எடுத்தது மட்டும் புரியுது. அது வரைக்கும் புரிஞ்சுது, அல்ல அது மட்டும் புரிஞ்சுது, அதுக்கப்புறம் புரியல. ஆரம்பத்திலே சொல்லியிருந்தா நமக்குள்ள தானே பரத், நமக்குள்ள என்ன இருக்குது? முகேஷ் எல்லாம் இன்னைக்கு எவ்வளோ அட்டி கொடுத்து அங்கே போய் அது சீக்ரெட் ரூம் இருக்குது, ரொம்ப தொந்தரவு பண்ணிங்கன்னா அந்த ரூமுக்குள்ளே போய் முகேஷ் அப்படியே இனி எங்கே வரையிறது? இது பாருங்க பரத், ஓகே டவுட் லேட்டாக கேட்டிருந்தா சின்ன டயக்ராம் தான். சி இதொரு டம்ளர், என்ன சொல்றது? சரி, கம்ப்ளீட் திஸ் I'll explain again. தஹசீன் யாரு? ஃப்ரெண்டா? இங்க வர்றது இல்லைல்ல, புரிஞ்சுது. ஜான்சி அதுவும் வருது, அது உங்க ஃப்ரெண்ட் தான். சரி முடிஞ்சுச்சா? இங்க வராதா தங்கம்? நம்ம வந்து இங்க போட்டி வந்து இந்த ஆளும் இந்த ஆளும் தான். இது அரை.
H is h1 plus h2 by 2. Substituting that, it should be whole square. h1 plus h2.
ஹோல் ஸ்கொயர் தான். ஹோல் ஸ்கொயர் எக்ஸ்பேண்ட் பண்ணியிருக்கிறது தான் இது. h1 plus h2 by 2 the whole square பண்ணும்போது h1 square plus h2 square by 4 வரும் இல்ல, அந்த 4 இங்க h1 square plus h2 square plus 2h1 h2 அது இங்க மல்டிப்ளை பண்ணி எழுதி இருக்கு. இது எப்படி வந்துச்சுன்னா இதோ இந்த மைனஸ் அது அது எப்படி உள்ள போகுதுன்னா right from the beginning. Okay, finished. So in the this minus is extra. Can anyone look? This minus is extra. How to solve this?
Sir, minus delta. W is equal to minus delta.
W is equal to
Minus delta U.
so plus correct ah?
Yes, sir.
இங்க மைனஸ் இங்கே மைனஸ் இங்க பிளஸ் அப்ப இங்க மைனஸ். இப்போ நிம்மதி ஆயிடுச்சுல. Okay, done. Okay, we'll explain once again. Okay, slowly. இப்போ okay, done. Last year batch நல்லா படிப்பாங்க ஆனால் யூஸ் டு பி கொஞ்சம் ஃபன்னியாக கூட இருந்தாங்க. பர்டிகுலர்லி அங்கே 2 பெஞ்ச் இருக்கு, யூ ரிமெம்பர்? ஸோ just if they take a little water வாய்க்குள்ள இருக்கும்போது some discussion will be there in the class, no, they will start feeling to laugh. தண்ணி இறக்கவும் முடியாது, வெளியே எடுக்க முடியாது. ஸோ அந்த மாதிரி நிறைய they used to drink a lot. ஸோ அப்படி குடிச்சிட்டு இருக்கும்போது இப்படி ஆயிடும். one girl spitted also. ஸோ அந்த மாதிரி அந்த 2 பெஞ்சு. Okay, right. See students, the thing is question number is 42. Yes. So this is a container. Bharat, this is another container. Here the water is up to a height, say h1. In this the water is up to a height h2. Now what happened is we connected this one. After making the connection, the height of the water became equal. Okay, say h. Okay, so what is the work done to make this height equal? Okay, what is the work done by the gravity while connecting this and to make the height equal? So what we are doing? The potential energy of this one, suppose if this is the center of mass, then the height of the water can be considered as h1 by 2. h1 by 2 because if ஒரு சின்ன ball இருந்துச்சுனா if it is at a height we will be able to say this is the height. This full water is there at that height, only surface is at h1. So how can we claim that the water is at a height h? Completely wrong statement, correct or what? So adanale what we are considering is whatever be the height of center of mass, we will be considering that as the height of water. Then so the potential energy of this one is nothing but mgh1 by 2, and this one is mgh2 by 2. Mass is equal to volume into density. Volume is area into height into density. So that when we substitute here, we will be getting a rho h g, this is h1, then h1 by 2 will come. This one is going to be a rho h g h2, this is 2 by 2. So finally its kinetic potential energy is going to be a rho g h2 square by 2, and this is going to be a rho g h1 square divided by 2. This is potential energy. The potential energy of the whole system is going to be how much? This is initial, if we say E divided by 2 h1 square. First one, this is doubt irukudha. Now when we mix this, what happens here? It is going to be the potential energy is going to be a rho g. Suppose if this height is h square by 2, this is the center of mass. Then here the potential energy is going to be a rho g what? H square by 2. Here the center of mass. So the total potential energy of final is going to be a rho g divided by 2. Okay, what will happen into 2? A rho g, this is going to be 2h square. 2h square, correct or what? Okay, இப்படி தானே எழுதுனீங்க 2h square. So this is the first kinetic potential energy, second potential energy. Now work is equal to the change in potential is the negative of the work done by conservative force. So work done by conservative force, which is nothing but the gravity, is always what? Change in potential energy. Now this h can be written like what? Whatever be h1 and h2, this can be written like, so if we substitute here, this is going to be a rho g divided by 2 into 2 is, this is going to be h1 square plus, okay, so this is going to be h1 plus h2 divided by 4 square. Idhula is a doubt irukudha. This is how it is going to be. Okay, now change in potential energy is going to be this minus that. So a rho g, I am taking this square and 4 I am taking outside. This is going to be h1 square plus h2 square plus 2 h1 h2, okay, minus the sum of the that is going to be a rho g by 2 h1 square plus h2 square. இப்படி இருக்குது. Okay, now if we multiply inside, this is going to be a rho g by 4 into h1 square plus h2 square. இதுக்கு மட்டும் I am multiplying inside. Now for this one alone, we are a rho g by 4 into 2 h1 h2. This one is minus a rho g by 2 h1 square plus h2 square. This term and this term are same structure. Idu kaal ara. So this is going to be a rho g by 4. This is h1 square plus h2 square, and this is going to be, if we take it outside, this will become what? this one minus here minus yes. Okay, so this is 1 by 4. So when you subtract from this 1 by total minus enga pochu adinga irukilla. Okay, okay, okay va, this will come correct or what? Okay, so this is going to be what? A rho g by 4. So here this will become plus, this will become minus. We will have h1 minus h2 the whole square. Correct or what? So this is correct. Option D. Correct? Okay, clear? Oh. Shall I erase this? Bharat, understood? Okay, fine. Shall I erase this, friend? All of you? Sudarshan? எல்லாரும் நான் அந்த மைனஸ் போட்டதுல கஷ்டப்பட்டது பார்த்து சந்தோஷமா சிரிச்சிட்டு இருக்கேன். சாருக்கு ஒரு மைனஸ். இன்னும் உங்களுக்குள்ளே மைனஸ் போட்டி இருக்குது போல. Okay, right. Next question. Come on, quick. Question number. Question number 43. Question number. உங்களுக்கு அந்த ஆன்சர் கிடைக்கலையோ? கிடைச்சது. அந்த மகளுக்கு அவங்களுக்கு கரெக்ட் தான். அது ஐ forgot to minus of minus x plus y on the top. கரெக்ட் தான். x minus y அவ்வளவுதான். x minus will come. See, enachna, see nothing. This delta you write, this minus அங்க வரைக்கும் எழுதிட்டு இங்க எழுதும்போது I did not copy that minus there. அதனால தான் அது வந்துச்சு. See, you do one thing. Just after going home கொஞ்சம் நிம்மதியா just போட்டு பாருங்க. You will get அவ்வளோ டீல் இல்லை. That is not a very big difficult problem. கொஞ்சம் கேர்ஃபுல்லா ஹேண்டில் பண்ணணும், அவ்வளவுதான். Okay, next question. If g is the acceleration due to gravity on Earth's surface, the gain in potential energy of an object of mass m raised from surface of Earth to a height equal to the radius of Earth. Okay, that is a question. Question number. Enna question number edu? 43. Okay, so u is equal to minus g mm divided by r. This is the general formula of potential energy. Okay, this r is not radius of Earth. This r is the distance from one center of one mass to the center of another mass. Suppose if we keep at a height h, what we do? G mm divided by what we do? R plus h. R plus h. If it is, this is radius of Earth. If we keep at a height h, what will be the formula? Minus gmm divided by, instead of r, c. Okay, so this is radius of Earth. Suppose if we keep at some height, then this is actually r. So this r is nothing but r plus this height h. This is how we are writing generally, correct? General formula. Now what is the question? In the question they are asking like they have kept at a height equal to radius, okay. Now what is G, children? Gm by r. So I can write this is going to be minus grm, correct or what? Divide by r plus h. Can I write like this? Correct or what? Okay, simply I substituted gm by r and g, correct? Okay, now look at the question. Gm by r square, correct. This is correct. Yes, true. Thank you. Okay, so G is Gm by r square. So we will have r plus h. Any doubt in this? Okay, then if you understand this one, then only you will be able to solve that problem. This is completely from gravitation. Already you have completed gravitation. Okay, look at that. Any doubt is there? Please ask. Clear? Done? Now look at the question. That h is actually r. That h is actually radius r. So now this is going to be, see children, u is equal to minus mg r square divided by, now for convenience what I am going to do, I am taking this r outside, 1 plus h by r, this r will be cancelled off, minus mg r divided by 1 plus r plus r. புரிஞ்சுதா? அப்படி போடலாம். I am just explaining. Whatever way you if you are comfortable, just solve it. Okay. I am just explaining right from here. Students, all of you may not be comfortable if I start from here or if I start from here. Directly I can write this. We can this question can be solved from here. U is equal to minus mgr by 1 plus h by r. This is the answer. From here only the answer comes. And just simply saying this one, anyway everyone should remember. This formula also everyone must know. So if anyone is not remembering these things, from gravitation plus note down. Okay, now what? R plus r, 1, this is going to be minus mgr divided by 2. That's it. Done? Clear? Any doubt in this? Shall we move to next question? Purila? Minus ennappa? Minus you just ignore. Minus is not there in the option, no? Just leave it. Minus is not there in the options, so ignore it. Otherwise, for potential energy, minus will come.
So they lost gain in the potential energy. MGR minus MGR.
Okay, gain in potential energy they have asked. Okay, so gain in potential energy means, gain is what? Gain in potential energy compared to the surface. Okay, in potential energy, mgr, this 2. Okay, so how much will come? Plus mgr. That is the difference in potential energy or gain in potential energy. Clear? Clear? Done? Okay. Next question, pa. Now work done itself is gain in potential energy. Work done itself is gain in potential energy. If you do like this, that negative will not come. Otherwise negative will come. If negative comes in the question, then work done is gain in potential energy itself. Okay. Right. And next question number 44. The work done, the body is falling under gravity, which question number 44. Okay, that leave it, that you can do no. Question option D. Okay, easy question, direct question. Work done in raising the mass from ground to a 1 meter height. Option D will come. 0.15. Question number 45. Question number 45. A body is falling gravity. When it loses gravitational potential energy by U, its speed is v. The mass of the body shall. Question number 45. A body is falling under gravity. When it loses potential energy by U, the speed is v. Okay, so the gain in the mass of the body will be, so loss in potential energy is u. Okay, loss in potential energy is u. So that time its speed is v. So this is going to be the loss in potential energy will be the kinetic energy. The loss in potential energy will be the kinetic energy. Then what they are asking? They are asking mass. So 2m by 2u by v square. 2u by v square. Option C. Question number 45. Okay, clear? Next question, question number 46, that you can do yourself, same thing. Okay, a liquid of density D is pumped by a pump P from station 1 to situation 1 to situation 2 as shown in the diagram. If the cross section of each of the vessel is A, then the work done in pumping. Question number 46. So work done in pumping is nothing but change in potential energy. Question number 46. Work done in pumping is change in potential energy. So just like the previous problem, you can find the potential energy of both. Okay, so please do it yourself. If you have any doubt, tomorrow you can ask. Clear? Purnama? Try pannunga, you will get it. Any doubt? Clear done? Okay, next question. AC கம்மி பண்ணுமோ? கம்மி பண்ணலாம். Question number அடுத்தது 47. Question number 47. So previous problem, the answer you are going to get will be option D. This one is going to be D. Okay, verify. Just like similar to the problem we have done. Right. Next question. The mass of bucket containing water is 10 kg. The mass of a bucket containing water is 10 kg. What is the work done in pulling up the bucket from a well of depth 10 meter? The water is pouring out at a uniform rate from a hole in it, and there is a loss of 2 kg of water from it. So the mass of the bucket at the bottom was 10 kg. So the mass of the bucket reached when it reaches the top is going to be 8 kg. 2 kg is slowly it is leaked out. So what they are asking is what is the work done in pulling up? What is the work done in pulling up? So work done in pulling up is actually force F dot S. So here you can do one thing, you can take the average force. Okay, so what is the average force? Previously it was 10 kg. So weight is going to be 10 kg. So this is going to be 10 into 10, that is 100. So when it reaches at the top, when this was at the bottom, it was 100. At the top, this became 8 into 10, 18 Newton. So I could say the average force is going to be 100 plus 80 divided by 2, going to be 90 Newton. So I can have 90 into, how much is the depth of the well? 10. This is going to be 10. So
Why are you taking your average force?
because this force is not constant. So this is the well. Okay, if this is the well, if this bucket, this is actually 10 kg. So that time its mass is mg, mass is m, this is going to be mg, so this is going to be 100 Newton. When this bucket reaches the top, so a hole is there in this bucket, so water it is leaking, so 2 kg is leaked out. So this is going to be finally 8 kg. So mg is going to be 80 Newton. So if it is given in the form of function, we would have done? We would have done W is equal to integral f dx or f dy, something like that. That is not there. So if we apply integration, the small work done for the small change in force and all, if we do, it is going to be very lengthy process. Whatever answer we are going to get from that is same as taking the average force of where it is, this one. So exactly the beginning force and the end force, if we know, always we can take the average F1 plus F2 by 2. Same, just like the same case, the bottom, the pressure is something, at the top pressure is another. So side wall, how we have taken the force? Average force only, same way. If you know the beginning and end, we can take average like this. Clear?